Cirrus Migrate On-Premises, CMO, allows you to migrate any block storage from on-premises storage to any cloud, including Azure. For this migration case, we'll migrate from an on-premises Windows Fibre Channel host device to an Elastic SAN volume over iSCSI. The first step is to create an Elastic SAN, which is a cloud-native storage area network solution at Azure. Elastic SAN is a fully integrated solution that simplifies storage deployment. We've already created an Elastic SAN 01 volume group that currently has no volumes. Now we'll create and add a new volume to it in one of the regions that supports this storage, such as France Central or Southeast Asia. Next, we need to build a VM in the same region. We'll create a Windows 2019 VM instance in the same region as the Elastic SAN, and we'll attach the newly created Elastic SAN disk. At the Azure portal, we'll connect the new Elastic SAN disk to the Windows 2019 server. From the portal, get the PowerShell iSCSI commands to add the iSCSI target, and then log into it in the remote desktop window. Before connecting to the VM, we'll open all the inbound and outbound ports to send and receive data to and from the VM. This is needed in order to be ready to migrate user block data databases from on-premises to the Azure Cloud VM. Connect to the Windows VM using RDP and log into it with the username and password. Open the Windows PowerShell as an administrator and run the two iSCSI commands to add the Elastic SAN volume. We've created a second Elastic SAN 02, that will have the destination volume on the virtual DMS 9000 SZ Linux VM target for this migration. In the interest of time, we're not showing, but we've already created a new 10 gig target volume in the volume group, which is ready for the migration. Open a PuTTY terminal and connect to the Linux VM DMS 9000 SZ. Open a second PuTTY terminal to the Fibre Channel switch where the Fibre Channel server pair DMS 1A and 1B are connected on premises. This will be the migration source. From the Azure portal, get the iSCSI commands for Linux and run them in the PuTTY terminal. Verify that the iSCSI target was added successfully and connect to the target. Next, open a browser to the Management GUI web page of the migration appliance, log into it, and navigate to the destination storage page. Click on the Storage Devices tab to rescan the devices. After the rescan is finished, the storage device with the attached volume should appear in the list. Select the device and select on the Rename Edit Devices option to change its default name if needed. Click on the iSCSI Targets tab, click the plus button to bring the migration target into view. Observe that there's an appliance iSCSI initiator and the discovered iSCSI target worldwide port name. Click and open the Enlist Devices drop-down and click on Remote Migration Resources. Click on the Migration tab and select Migration Targets. Since there are no migration targets present, we'll click on the plus sign to add them. In the pop-up window, click the Select button and click on Add New Client. Enter the username and password and click Save. Back on the Storage Server Client screen, click the Select button on the left of the client name. After clicking, it immediately goes back to the Migrate Target screen. Enter a name for the target name, and also click the checkbox to select the device. Then click Save. This completes the creation of the migration target with the remote migration resource. Next, we'll add and connect the remote storage server on the source CMO pair. Log into the Management GUI, navigate to the Destination Storage page, and click on Remote Storage Targets. Click the plus button to connect to the new target. On the Connect to Remote Storage Server screen, enter the IP address of the remote migration appliance. Type in the username and password and click Save. The source migration appliance will make a connection to the destination appliance. The remote target information and connection status is displayed. Click on the Storage Devices tab and the remote migration resource will be listed as well. To confirm that the source migration appliance can access the remote migration LUN, select the device and click the Test Devices button to perform a test. The test result shows the latency and throughput. From this point on, we'll perform a path insertion of the source migration server between the local storage on-premises and the Azure iSCSI device. We'll migrate an on-premises 2 gig block disk volume to Azure. First, we'll perform storage-side logical insertion using a pair of Cirrus Migrate On-Premises servers. We'll insert DMS 125 Nexus 1 for VNX Target 1 first. Click the Insertion Wizard for DMS 125 Nexus 1 to insert Target 1. We'll follow all the steps that are shown in the Insertion Assistant webpage. There's a list of required information that will be needed. To show some I/O at the source Windows 2016 VM, we'll start Iometer on the 2 GB on-premises device to be migrated. Open the insertion wizard at step 3 and add the information defined previously. When we get to insertion step 4, we'll click here to collect the fiber channel switch info. At step 5, we'll see the commands necessary to create the insertion vSAN 103. Click Execute Command and click OK when done. Step 6 contains commands that create additional zones for the insertion vSAN 101. We'll snag these and execute them on the fiber channel switch. Insertion step 7 provides commands that perform the actual insertion to move the source storage target port from the production vSAN 1 to the insertion vSAN 103. At the insertion wizard, click Execute Commands. We'll bring Iometer to the front to observe there's no downtime during this insertion. At the Management console, click OK when complete. At the SAN Configuration tab, click on Topology Explorer to see there's a path from the host to VNX EMC1 storage. Click on the Nexus tab and note that DMS125 Nexus 1 is inserted. We'll repeat the same insertion process for the secondary DMS126 Nexus 1. At the end of the second insertion, at the SAN Configuration tab, click on Topology Explorer to see that there are now 2 paths, from host 001 to the EMC1. Next, we'll configure the remote storage target on the virtual server on Azure. We're now ready to create the migration session and run the migration. Click on the Migration Session tab to open the Migration Session wizard. Right now, there are no migration sessions, so we'll click the plus sign on the right to create a new migration session and select the Windows 2016 on-premises source host. 4 source LUNs are shown. Select one of them as the source. Select the destination type Migrate to Remote Resources. Click Next. Now we'll schedule the migration. Select Moderate and add the new migration. Then click Next and Finish. Finally, we'll click OK to start the migration. Observe that a new migration session kicked off, migrating the 2 GB on-premises volume to the newly created Elastic SAN volume. Open Iometer again and observe that the I/O continues undisrupted. Wait until the migration ends. In the Source Windows RDP, open File Explorer and verify that there are several files on the source volume. The migration is now in the pending complete state, and will sync the remaining change blocks to the destination. This completes the migration, and Iometer is running now at the Azure Windows 2019.